roots of complex numbers. First thing we need to learn is something called de Moivre's theorem. I don't even know if I'm saying that right, but if any of you speak French, you could help me out. De Moivre's theorem says we can find the power of a complex number by taking the radius, the magnitude, to the power that we're trying to take that number to. And then we just do the cosine of that power times theta plus I sine theta, and there's your formula to find powers. Okay? Let's do an example. Simplify negative square root of 3 plus I to the 8th power. Okay, what if we didn't know about trigonometric form and we didn't know about de Moivre's theorem? How would we do this if we didn't know that's what we know? Nope. You would FOIL this 7 times. You would go negative square root of 3 plus I times negative square root of 3 plus I, and you would get negative 3 minus 2 square root of 3, 2I square root 3 plus I squared, and you would change the I squared to a negative 1, so you would have negative 4 minus 2I square root 3, and then you would multiply negative square root of 3 plus I, and you would keep doing that until you'd multiplied it times itself 8 times. See, I told you this section is the power of the trig form. There's power in doing powers in trig form. Sorry. Blah. So I don't want to do it that way, do you? No. Okay, so we're going to scratch that method. And we are going to use de Moivre's theorem instead. The problem with de Moivre's theorem is that it has to be in trig form. Is it in trig form right now? No. So we have to have trig form. So to do trig form, we go inverse tangent of 1 over negative square root of 3. Ooh, this is an exact one that we know. Let's graph this really fast to make sure we're in the correct quadrant. So it would be negative that direction and positive that direction, so quadrant 2. So this is square root of 3 over 3. So what is the angle for square root of 3 over 3? It's a 30-degree reference angle. But because of where the point is when we graphed it, we found it in quadrant 2 because we go left and then up. We know it's a 30-degree reference angle in quadrant 2, which makes it 150 degrees. Yes? Okay. Next, we do the square root of the square root of 3 plus squared plus 1 squared. So the square root of 3 squared is 3, and 1 squared is just 1. So we get the square root of 4, which is a beautiful answer too. Right? So the trig form was not that difficult to find. 2 times the cosine of 150 plus I sine 150. Okay? So now that it's in trig form, we just need to use the formula. So we're going to the 8th power. What do we do? So our problem, this thing, to the 8th power can be done by using de Moivre's theorem. 2 to the 8th power times the cosine of 8 times 150 plus I sine times, of 8 times 150. Right? Okay, well 2 to the 8th power is a fairly large number. Good job. That would be taking 2 and multiplying it 8 times itself. 8 times 150, what is that number? Eight times 150 is 1200. So obviously, in order to do this exact, we would want to make sure we get it down to an angle in the between 0 and 360, correct? So we need to find a coterminal angle. So to do that, we take 1200 and we subtract 360 a bunch of times. Any idea how many times it takes to get it down to where we want it to be? 3 times, I'm pretty sure. So that takes us down to what angle? Good job. So now we have 256 times the cosine of 120 plus I sine 120. Okay, well the cosine of 120 is a 60-degree angle in the second quadrant. So what is that answer? Okay, cosine of 60 is 1/2, but what about second quadrant? Negative 1/2. Then sine of 60 degrees in the second quadrant is what? And is it positive? Yes, indeed. Okay, so now we just multiply it through and simplify it. So we have 256 times a negative 1/2 is a negative 128. And 256 times square root of 3 over 2 is 128 times I times the square root of 3, because the 2 divided into 256. And there's our final answer. Now, how in the world would this have ever ended up back to that? How is it that that would have happened? Because won't this just keep getting more and more complicated? How can it have such a simple answer? If you kept foiling it out, you would always be doing square root of 3's times square root of 3's, which will just change to 3's, and they multiply in. And then anytime you have an I squared, that turns into a negative 1. And so just every time you FOIL it out, you can simplify the square root of 3 things and the I squareds. And it just so happens that it would simplify to that. If you want to do it and prove it, feel free. But I think this shows us the value of knowing trig form, because finding a power of a complex number now becomes much easier, right? Does that make sense? Of course, you're probably wondering, when am I ever going to want to find the power of a complex number? That, I'm not sure.